so far away from us that it is hard to tell how big or even how bright they really are. But astronomers can group them into categories by analyzing their spectra. See pp point 26 to 27, which differ according to a star's size and temperature.
Luminosity.
I was just about to say it. Luminosity and brightness. Luminosity is the energy a star emits each second. The brightness of a star as it appears in our sky is called the apparent magnitude and depends on both the star's luminosity and its distance from Earth. It is measured on a numerical scale in which the brightest stars are given negative or low numbers. The brightest stars have been values of around -1, only -1, and faint stars are given high numbers. The scale does not work in even size steps. A star with a magnitude of 1 is 100 times brighter than a star with a magnitude of 6. Luminosity. The size of the white dots represents the true luminosity of stars in the constellation Canis Major. But the stars that radiate the most light may not look like the brightest stars in the night sky to us on Earth if they are far away. Apparent magnitude. Here, the size shows the apparent brightness of the same Canis Major stars. Notice how Sirius looks much brighter because it is closer, but Aludra is 176,000 times brighter than the sun. Is quite dim because it's so distant. It's like 176,000. Can you believe it? Whoa. Okay. So, classifying stars. Stars can be classified using the H2R diagram. See left. Those that convert hydrogen into helium through nuclear fusion, CP.90, are known as main sequence stars.
Okay, the HR diagram HR stands for Hertzsprung-Russell diagram, which is this one.
Wow.
Okay, continue reading.
Okay, so are known as main sequence stars. These stars in the stable middle stages of their lives are located within a diagonal band in the middle of the HR diagram. main sequence stars are classified into 7 groups: O, B, A, F, G, K, and M. Those look like the letters of the alphabet. According to their spectra, the patterns in the colors of light stars emit caused by the chemical elements they contain. These spectral types run the hottest O type.
Run from
The hottest O type down to the coolest M type stars. Only as white dwarfs and supergiants fall exhausted, their supply of hydrogen and helium and become exhausted. The HR diagram. This famous chart was named after astronomers Edgar Hertzsprung and Henry Wessel. It illustrates the relationship between a star's temperature and luminosity. Stars remain curved on the curved diagonal main sequence for most of their lives. Low mass stars are red and at the bottom right. Okay. Blue stars at the top left have the highest gas masses. Giants and supergiants, which have exhausted their helium supply, lie at the top right. Like the top right. What is the biggest star? Sirius, also known as the dog star, is the constellation Canis Major, which is the brightest star, with an apparent magnitude of negative 1.47 point. Okay.